remove natin yung support B, and then this is the applying the reaction at B. And then yung typical deflection based on the table I gave you, eto po, yan. So, dun sa concentrated load, at an arbitrary constant B, so we have this equation, PB over 48 EI multiplied by 3L squared minus 4B squared. Now, please take note of this. The B is the distance of P from the nearer support. So, if you will look at the problem, the distance of P from the nearer support, so yung 60, the B is 3. 60, the B is also 3. So, what we did here is, multiply na lang yan natin sa 2. So, ito yung equation for the 60 at an arbitrary distance from the beam. And then this is the deflection caused by the uniform load. And again, this is the deflection caused by the reaction at B. So, we did the same as earlier. We equated the 2. And then, just substitute, no? So, if you notice here, minultiply ko na lang siya sa 2. Why? Because the same lang yung equation na gagamitin for the 260. Diba? 60, the B is 3. 60, the B is 3. So, just use one equation, multiply it by 2 para mas maikli. Here it is 2 times 60 times 3. And then, substitute the values. The L is the total length of the beam. The B is the distance of the concentrated load to the nearer support, and then 5WL raised to the 4th. Now, to those who ask, no, EI will be cancelled kasi, di ba, meron pa sa kabila. Makakancel lang naman ng EI. So, EI will be cancelled. What will be left here is your RB. So, solving this, you will get your RB, which is equal to 270 kilonewton. Now, to get your RA and RC, since this is symmetrical, all you need to do is add all the forces, subtract it by RB, and then divide it by 2. The next step will be drawing your shear and moment diagram. Again, to draw your shear and moment diagram, this was already taught, no, in your structural theory 1. So, papakita ko na lang yung figure. Now, dun sa mga problem na ibibigay na always yan, you need to draw the shear and moment diagram of the final answer. So, after nyo ma-compute yung reactions, you will need to draw the shear and moment diagram. So, I suggest that you review your structural theory 1 and how to draw your shear and moment diagram. Okay, so, any question? Okay, so I take this as none. No, so let's go to the second example. If you notice here, this second example is the same with the previous example. Now, ang difference is here, the support B settles 18 mm vertically down. So, magkakaroon tayo ng additional 18 mm to consider. So, first, di ba? First step, remove the support at B. So, this will be the equation. What will happen is, we need to add the deflection at B, and then add the 18 millimeters. So, ganito yung mangyayari. Okay, so just copy the equation that we used earlier. Okay, so let me correct this one. So this 18, sorry about this, should be negative. Because based on the equation, the deformation that of your support at B should be equal to the settlement and the deflection of the load. So, di ba, yung general equation should be delta B is equal, we have delta B is equal to, ganito dapat yan. So, transferring yung 18, this should be negative. Correction. So, yan. This should be negative. That should be negative. Instead of plus 18, this should be minus 18 because it's from here. No? I-add natin yung load, deflection ng load, and then yung settlement. And those two should be equal to your deflection caused by the support. Tingnan natin. Ulitin ko. This is negative. So what do we need to do? Now, since this 18 is in millimeters, millimeters yan, we need to, again, in solving any type of mathematical problems, no, the units should be the same. Para makuha nyo yung correct answer, you need to convert everything in the same unit. So since this is in millimeters, you either convert your length into millimeters. Etong L, since this is 12 meters, na gagawin yung 12,000 millimeters. Or, ito ng mm ang gagawin nyo into meters. So, you only have two options naman dyan. So, here ang gagawin natin is let's convert the loads into millimeters and Newton para uniform. So, let's see. Yan. So, kung papansin nyo, what I did here is, nawala yung naging 8 siya, diba? Ang ginawa ko dyan is, we simplify first, no? Multiply natin siya sa 48 EI. If you multiply it with 48 EI na makakancel to, ito, then yung 384 will be 8. So, simplify first for a shorter solution. And then, every load here is convert natin into Newton. Ang lahat naman ng distance will be converted into millimeters. So we have 25 kilonewton per meter is the same with 25 Newton millimeter. So you don't need to add a multiplier. Diba? Kapag i-convert mo siya, just 1,000 divided by 1,000. So similar. So this is 25 Newton millimeter. Same yung unit. Ito 12,000. This is mm. Double check always. So you have PB. P is 60. Ito na P. Ang B natin is 3. Now, so times 1,000. So ginawa ko na lang 1,000 squared. No? 60 times 1,000 and then 3 times 1,000. Then the same here. 3 times L squared. 12,000. Naka-mm sila. 4 times mm. So then, 12,000, naka-mm. So, yun. So, the 48 EI is from here. And then, simplify this. We will get the value of your RB, which is 220 kilonewton. Now, let's see the difference from the earlier problem. Let's check now. Okay, so here, dito kung mapapansin nyo, the reaction at B is 270 kilonewton. But with the deflection, with the settlement, the reaction at B is now 220 kilonewton. So, nagkaroon tayo ng difference na 50 kilonewton because of the 18 mm settlement. Okay, so again, here, madali lang naman yung ginawa natin. All we did is substitute the value of your itong 48 EI now, we have here your E and I also in megapascal or Newton millimeter. Megapascal is Newton millimeter squared. Then you have your mm4. So everything is in Newton and mm. So if you don't want this, convert nyo naman lahat into kilonewton and meter. Okay lang din naman yun. As long as you only stick to one unit. Because if pagsama-samahin nyo yan, of course, mamamali kayo ng answer. So then, again, just simplify. You will get your RB. And then after getting your RB, do the same process to get your RA. No? Summation of forces vertical minus RB divided by 2 to get your RA and RC. So here, your RA and RC is 100. So if you'll notice, yung settlement natin sa B is nag-cause na lumiit yung RB and lumaki yung RA and RC. So this is the shear and moment diagram. So, correction. Yung correction ko na, baka kalimutan nyo, this should be minus 18. Please remember yung 18. Okay, so let's have another example. Yan, we have here a compound beam or a cantilever beam with a hinge or a roller at the free end. So first, analyze the indeterminate beam shown. So no settlement present. So all we need to do is equate the deflection or deformation caused by the loads and the deformation caused by the support. So here you actually have two options. Since this is a first degree statical indeterminate structure, diba? If we are to draw the reactions, we have 1, 2, 3, 4. So this is 4. 4 minus 3 is 1. So this is a first degree statical indeterminate structure. Now, as a redundant, we need to remove one reaction. Now, here you have two options. You can remove the support B. So you will be left with a cantilever beam. Or you remove the moment, and you will be left with a simply supported beam. Now, in my solution, I remove the support B. That's what I did. C. And so first step, remove the redundant or remove the support reaction. Okay. So what I did here is, para hindi siya confusing, I separated the two loads. First is the uniform load, and then the other load is the 48 kilonewton. Now, if we will based on the table, if a cantilever beam is subjected to a uniform load, the formula for deflection is WL raised to the 4 over 8 EI. Now here, so also I labeled it as 3, no? Kung mapapansin nyo, we have delta B1. Delta B1 is the, that line. Delta B1 is this one here, yung settlement caused by the uniform load. Now ito, kung mapapansin nyo, I have labeled here delta B2 tsaka delta B3. Now why is that? Because kasi dun sa table na binigay ko, we don't have an equation for a cantilever beam na wala sa free end yung load. So, ang meron lang tayong equation is ganito lang. The only equation we have is for a cantilever beam and the concentrated load is at the mid. It's at the free end. So what I did here is, kunin natin yung deflection dito sa point na to. Ayan. That is your delta B2. So the equation that here for this delta B2 is the same with this one. Kasi parang hinati lang natin, no? So ito yung delta B2. Ito siya. Now, how about delta B3? Paano natin siya makukuha? So, for the total deformation or deflection at the free end, we need to add delta B2 and delta B3. Now, how do we get this delta B3? Now, since ito yung equation natin, we can actually also get the slope at that point, which is also given dun sa table. So, ito yung equation para sa deflection. Ito. Now, for the slope, pwede natin siyang makuha, and then all we need to do is, if this is theta, di ba? Kung mapapansin niyo, ito yung triangle. I-redraw ko. Ito, mangyayari niyo. If this is theta, the opposite is delta B3. And then this is your distance, x. We can just use the tangent function. Tangent theta is equal to the opposite, delta b3, over the adjacent, which is your x. So, if you are to get your delta b3, diba, it is equal to theta x. Now, why theta x? But we eliminate yung tangent. Now, since the angle here is relatively small, pwede natin i-neglect yung tangent. So, kasi kung, for example, gawin mo siyang tangent 0, 0, 0 theta, if itry mo yun sa calculator, that will be just equal to theta. So, pwede natin siyang i-write as theta x lang. So, by using this relationship, we can actually get your theta b3. Because yung theta, sa paano natin makukuha yung theta, we can just use the equation for this type of cantilever beam. And then multiply it with the distance. Now, in this example, the distance is 2. So, the slope multiplied by the distance is equivalent to this remaining height. So, yon ang mangyayari ganito. So, the delta B3 is equal to theta x from this one. Or, wherein your x is equal to 2 meters, since this is 6 minus 4, 2. And then, this is the equation. No, this is the equation based on the table of the slope. And then, multiply it by 2. Then, to get the final deflection by the load, all you need to do is add delta B1, delta B1, delta B2, and delta B3. So, ganun yun lang yung gagawin. Check natin. No? All you need to do is add the 3 equations. Apply the reaction at B. So, same lang to ng cantilever beam with load at the free end. So, yun. Kung mapapansin nyo, same yung equation. PL cube over 3EI or BL cube over 3EI. Then, equating this reaction, equating this will give us your RB. So, now we have here RB is equal to 78.89 kilonewton. Now, if meron na kayong RB, madali na lang pag-compute ng RA and MA. Of course, we don't have horizontal reaction here since we don't have your horizontal load, no? So, ang i-compute nyo na lang is RA and MA. Now, again, this is just computation of reaction, so I will no longer discuss this, no? You should be able to compute this. So, after nyo makompute kasi yung isang reaction, di ba, magiging siyang statically determinate. So, pwede nyo nang gamitin yung equations of equilibrium. And then, after computing for your reaction at A and moment at A, we will draw your shear and moment diagram. Okay, so, would you like me to explain yung shear and moment diagram or wag na? Recap lang? Okay na to? Okay, so, check natin. Tama ba? Okay na kayo sa shear and moment diagram, no? I will no longer discuss this. Okay na to? Again, yung pag-compute, all you need to do is, for your RA, summation of forces vertical to get your RA, and then do summation of moment to get your moment A. Also, I noticed most of the mistakes are nanineglect i-compute yung moment. Please always remember that in a cantilever beam, there's always a moment at that support. Okay, so any question or clarification? None? Okay, so this will be the last example, I think. Yeah, this will be the last example for your method of superposition. Okay, so may nagtanong, no? So sige, explain ko lang. How did we get your 109.78? Okay, so recap lang, konting recap from your structural theory 1, how to draw your shear and moment diagram. So here, please use your calculator. No? So, hindi ko na i-correct yung pag-compute ng reactions ha. You already know how to compute this. So, di ba, in solving or in drawing your shear and moment diagram, always start on the left side of the beam. Always. Kahit pa nandito yung cantilever support, always start from left to right. Now, since moment is a moment, of course, you don't use this sa shear diagram. So, for the shear diagram, let's start with the reaction A, 113.11. It's going upward, so upward in yung force. Ayan. Upward, 113.11. And then, from A to this point, meron tayong uniform load that will cause a uniform change. Since, kung mapasan yung pababa, so since uniform yan, obviously, pababa din yung changes na makikreate niya sa beam. So, yung 113.11, subtract nyo sa area nito. So, 113.11 minus 4 times 24 will give you 17.11. Yan. And then, at this point, you have a concentrated load 48 that will cause an abrupt change. So, 17.11 minus 48 will give you negative 30.89. And then again, a uniform load or gradual change. So from 30.89, subtract natin yung 24 times, this is 2, will give you negative 78.89. Okay, and then this will be your area 1. And then area 2, no? Diba ganyan yan? And then copy the 150.66. Always remember, kung saan naka-point yung arrow, nandun yung moment. We have here 150.66 negative, and then add this area. Add yun lang yung area. Now, this is a trapezoid. Negative 150.66 plus the area of this trapezoid will give you 109.78. Then 109.78 minus area by the second trapezoid should be equal to 0. So, area of the trapezoid na 113.11 plus 17.11 divided by 2 times the distance. So, if hindi nyo pa alam yan, I suggest you recall your areas. No? So, yan. Now, again, for those medyo confused pa sa shear and moment diagram, I suggest you review that.